We are working on applications of linear equations. There are lots of application problems for linear equations, but we're going to focus on just a few different ones. So you're going to have to set up a linear equation for an application problem. You're going to have to solve the application problem using that linear equation, and then you're going to label your solution for that application problem. So let's look at a few types that we're going to be solving here. So it says write an equation for each problem, so you can't just kind of guess and try to figure out the numbers. You can, but you won't get all the points for it. If it's worth 3 points, you would get 1 for the solution and you'd miss all the other points. So make sure you know how to write the equation, show your work for that, solve it, and then label it. So let's look at this one here. We've got 2 buses, and sometimes it kind of helps to draw out kind of a picture of this. So they're leaving the town of Houston, the city of Houston here at the same time. They're traveling in different opposite directions. So let's say one's going this direction and the other one's going this direction. So one bus there is traveling faster, so obviously that one's going to be able to go farther. So this one bus, we'll do bus 1 over here because he's gone farther there. So you got to remember this formula. It's called distance equals rate times time. So how we can do that is the rate there is a speed, so it's the same thing. How fast are they going? And so its speed here, bus 1 speed there is 55 miles per hour. And times time. Oops, not times. Time. There. So the time there that it's going, it says, when will they be 400 miles apart? It's not given a time. We don't know that. So let's just call that x. So we're going to say this is 55x. All right. So what about bus 2? So the nice abbreviated version here is d equals r times t. So let's come over here and let's do bus 2. I know they call it other bus. I'm going to call it bus 2. So bus 2 here, distance equals rate times time. Its rate there, how fast it's going 45 miles per hour. And times its time, and it has the same time as bus 1. So its total distance there traveled is 45x. So between bus 2 and bus 1 here, the total distance there is 400 miles. So if we take our distance for bus 2 and we take our distance for bus 1 and we add them together, that should give us the total distance there of 400 miles. So that's what we're going to do. We're going to take 45x, which is bus 2, plus the distance there for bus 1 there is 55x. The total distance is 400 miles. So we're going to go ahead and just solve this for x. So basically x equals the time each bus traveled. All right, so 45x plus 55x there is going to give us 100x. We can divide both sides there by 100, and we get x equals 4 hours. Since it's miles per hour, that means the time there is 4 hours. So when will they be 400 miles apart? In 4 hours. As long as they don't stop. They just keep going. And they maintain that same speed. All right, so example 2 here, it says 2 planes left an airport at noon. One flew east and the other flew west at twice the speed. After 3 hours, the planes were 2,700 miles apart. How fast was each plane flying? So We have a plane going this way here. We're going to call this the plane going to the east. I'm going to call it PE. And then this one here is going to the west. We're going to call that PW. So let's look at the plane going to the west and the plane going to the east and see if we can set them up. So again, we're going to use distance equals rate times time because you can see we have a speed in there. We have time, hours, and we have distance, miles. So our distance for this one here, for the plane going to the west. So this one here is the plane flew east at a certain speed there. We don't know what that speed is. We're going to say its R is equal to X. And the other one over here is going twice the speed here. We're going to say it's going 2x. We'll just say x. So its distance there, or its speed there is x, and it says twice the speed, so we're going to call that 2x, the one that to the west. So this one here is 2x. And do we know the time? It says 3 hours. So our 3 hours there is our time. So we know this one. So D here equals 2x times 3 is 6x. Let's look at the plane going to the east. This is also distance equals rate times time. What's the speed of the plane going to the east? We call that x. What's its time? 3. What's x times 3? 3x. So maybe I should write this out. So x equals speed of eastern plane, and 2x equals speed or rate of western plane. Just so long you know what x and 2x there mean. So I can go ahead. Now I know that after 3 hours the planes were 2,700 miles apart. So that means 2,700 miles is the total distance. So if I say 6x plus 3x, so the plane going to the west there, its distance there is 6x. The plane going to the east there is 3x. If you add them together, you get the total distance there of 2,700 miles. So let's combine the left-hand side. 6x plus 3x there is 9x. Divide by 9, and x there is 300. So that is 300 miles per hour, and that's the east plane. And then what about the west plane? Well, the western plane is twice it, so you have to take 300 and put it in there for your x there. So your 2x there is 2 times 300, which equals 600 miles per hour, and that's for the west plane. And if I come up there, does that make sense? It says that the one plane flew east and the other flew west at twice the speed, so the western plane should be twice as fast as the east plane, and it is. It's 600 miles per hour for the west plane and 300 miles per hour for the east plane. All right, example 3 here. The length of a rectangle is 3 centimeters greater than its width. The perimeter is 24 centimeters. What are the dimensions of the rectangle? So I have a rectangle and I have a geometry problem, so a lot of times I like to draw out a picture here. So it says the length of a rectangle is 3 centimeters greater than its width. So since they're comparing the length there with its width, I'm going to say x equals the width. 3 centimeters greater is just x plus 3. If it was 3 times greater, that would be 3x. So this is just 3 centimeters greater, so that's just x plus 3. So that's the length. So if I put those on here on the rectangle, this is the 3x, x, this is x plus 3, and this is x plus 3. The perimeter, if you remember perimeter, that's just distance all the way around the rectangle, so you have to add them all up. So if I were to do the perimeter here, I would have to take x plus x plus 3 plus x plus x plus 3. And we know what the perimeter there, it's 24. So 24 equals, this is 1x plus 1x plus 1x plus 1x is 4x. And then I have this 3 plus 3 there is 6. And now I can just solve this. So I can subtract 6. So I get 4x there equals 18. I can divide by 4. And x there is 4.5. So my width is 4.5, and the label there is centimeters. My length is 4.5. I'm going to take that and I'm going to put it in there, plus 3, and that is 7.5 centimeters. Example 4. The measure of the supplement of an angle is 20 degrees more than 3 times the measure of the original angle. Find the measures of the angles. Something that you have to remember from geometry is that supplementary angles, they add up to 180 degrees. And then I'm going to remind you of another one here. If you remember, complementary angles, those add up to 90 degrees. And I'm saying both of these because both of those could be in your homework there, so you might want to write that down in your notes so you can refer back to that. So we're supposed to find the measures of 2 different angles, and we're just dealing with supplementary angles. So supplementary angles, if you remember from geometry, they look like this. There'd be a measure over here and then a measure over here. They're not necessarily the same there, but they have to add up to be 180. So it says the measure of the supplemented angle is 20 degrees more than 3 times the measure of the original angle. So let's say that x equals the original angle measure. Whoops, original. There's no a at the or no e at the end. All right, and then so it says the measure of a supplement of an angle is 20 degrees more than 3 times the measure of the original angle. So its supplement, it says 3 times the measure of the original angle, so 3 times, that would be 3x, and then 20 degrees more than that, so I have to add 20 to that. So that's its supplement. All right, so we're supposed to take the original angle and then add on the supplement's angle, and it's supposed to end up equaling us 180. So for instance, let's say this was x and this was 3x plus 20. You're supposed to add them together and get 180 because the distance from is half of a circle is 180, and 360 degrees is in a circle, and half of that would be 180. So I'm supposed to take x plus 3x plus 20, and it will give me 180. So I'm going to solve for x, so I'm going to add this 1x and this 3x, and I get 4x. I'm going to get 4x by itself, so let's get rid of the 20. So we get 4x equals 160. Then last, divide by 4, and x there is 40. So we've got 2 angles. We got the original angle is 40 degrees. And to get the other one, you could take 180 minus 40, or you could put 40 back in there. So if I put 40 back in there, 3 times 40 there is 120, plus 20 there is 140. Or, like I said, to find the other one, you could just take 180 minus 40, and you also get 140 degrees. So 40 degrees and 140 degrees are the two angle measurements. All right, and then our last problem here, it says, find 4 consecutive odd integers with a sum of 184. So let me kind of go through some, because again, we're going to have different types of problems that are like this. So let's talk about consecutive numbers first. So consecutive numbers are numbers that are right after one another. So consecutive numbers are like 1, 2, 3, 4. They're right after one another. Or 20, 21, and 22, and 23, or 55, 56, 57, 58. Those are consecutive numbers. What are consecutive odd numbers? I do not want to spell that word right. Those are odd numbers, so it'd be like 1, 3, 5, 7, and so on and so forth, or 21, 23, 25, 27. Those would be 4 consecutive odd numbers. What are consecutive even numbers? Because you're going to also need to know what those are. Those are your even numbers that are divisible by 2, so it's like 2, 4, 6, and 8. Those are your even numbers. So when you set these up, you are going to be looking at, if you kind of look at these up here, if they ask for consecutive odd or even numbers, you're going to set the setup for those are exactly the same. So consecutive, odd, or even. What happens here is x equals the first number, and then how do you get from, if I look up here at the odd numbers, that's 1, 3, 5, 7, how do I get from 1 to 3 there? So I'm looking at these right here, this second set here. How do I get from 1 to 3? I'd have to add 2. So this next one here is x plus 2 equals the second number. And then how do I get from 1 to 5? I'd have to add 4. It's all in terms of the first number. And then how do I get from 1 to 7? I have to add 6 to the first number. And of course, if they only asked you for 3 of them, you'd say x, x plus 2, and x plus 4 would be first, second, and third. If they only asked for 2 numbers that were consecutive odd, you would say x and x plus 2. Now the setup is exactly the same whether it's even or if it's odd, because how do you get from 2 to 4? You'd have to add 2, just like we did here. We said x plus 2. How do you get from 2 to 6? You'd have to add 4, so the first number plus 4 to give you 6. How do you get from 2 to 8? You'd have to add 6. So the setup is the same for whether it's odd or whether it's even. Now let me show you how you'd set up if they were just consecutive numbers. The first number here is always x, so we'd say x equals the first number. And then let's see, from the first number to the second number here, so we're looking at this set here from 1 to 2, you have to just add 1. So you'd say x plus 1 equals the second number. How do you get from 1 to 3? You'd have to add 2. How do you get from 1 to 4? You'd have to add 3, and so on and so forth. If there were 5 numbers, then you'd say x plus 4. So the setup for one like this, then you'd say if it was 4 consecutive numbers here, you'd say x plus 1 plus x plus 2 plus x plus 3 equals the total sum, whatever they tell you that is. So it's going to be some sum value, and then you would go ahead and solve for those. R's here, we're going to be working with consecutive, odd, or even in our problem here. So let me bring this back down here. So our setup here is going to be, because it asks for 4 consecutive, it's going to be x plus 2 plus x plus 4 plus x plus 6. And what's our sum? Our sum there is 184. And don't forget the word sum means add. Okay, so you're going to add them all together. So if we add these all together, 1x plus 1x plus 1x plus 1x is 4x. And then you've got 2 plus 4 plus 6 gives us 12, and it equals 184. I can subtract 12, and we get 4x equals 172, divide by 4, and x is 43. So what are my 4 consecutive odd integers? 43. And if you don't know what the next one is, come back down here to where our setup here is. 43 plus 2. So I'm looking here, 43 plus 2 there is 45. And then I can look at my next one there. What's the next one down here? Consecutive, 43 plus 4 is 47. And then what's my last one here? It's 43 plus 6, which is 49. So 43, 45, 47, and 49 are our values of what we're looking there for. So minimally, if you had to do this setup, I would expect to see this, some work shown, and then your final answer here. So some kind of work shown in here. So now you're working on the 1-7 worksheet.